Hello, everyone. Welcome to the second talk of the Career Talk series. My name is Tara Kapoor. I'm in grade 10 at Head Start Educational Academy. My brother Shiv and I saw this lockdown as an opportunity to help us all by bringing professionals from various domains to expose our students to a spectrum of careers. Today, we would like to invite Professor Karan Singh, who is a part of the Computer Science Department at the University of Toronto. He holds a graduate degree in computer science from IIT Madras. He later received a PhD from Ohio State University. He has worked in the industry initially and was responsible for a significant piece of software which was used all around the world in creating special effects and animation. He has even been awarded an Oscar for one of his creations. Just this week, Professor Singh received the prestigious President's Impact Award in Canada. We could congratulate him for that. Before we let Professor Karan Singh take over, we would like to share a couple of housekeeping rules with you all. Firstly, as moderators, we will ensure everyone except the speaker is muted throughout the call. Please don't try to unmute yourself. Secondly, kindly keep your video switched off during the entire call, as we will be recording this session and posting it on YouTube. Thirdly, you may ask any questions you have at any time during the session in the chat box. The second half of this call will be used to answer your questions. As moderators, we will pose your questions directly to the professor. Thank you. Professor Karan, please take over from here.
Unmute. Great. Thanks, Tara. That was a lovely little introduction. Wow, it seems to be a lot of people seem to be connected over here, so that's very exciting. And it's also quite different, actually, from a lot of the talks that I tend to do that are often more technical or more sort of specific.
Sorry to interrupt, Professor, please turn on your video.
My video, hold on a second. Here we go. Okay, there. So yeah, so it's actually a lot of fun to be talking to you all, and I'm actually talking to you from way down in the southern hemisphere. I'm actually sort of locked down, just like all of us, in Wellington in New Zealand, where I'm working with one of the better known special effects companies on some upcoming effects for a few films. So that's what I'm up to at the moment. But what I'd like to talk to you guys about today is generally the area of computer science and what it's like to work in that area, what it's like to work in my area more specifically, which is computer graphics, and generally, you know, how you might find yourself in that space with a career in that direction, if that's where your interest might lie. So I actually have a few slides. I'm going to try and see if I'm able to actually pop them up and share my screen with you guys. And if I am, then great. And if not, then we'll just go back to the video and keep talking. So I'm going to try and see if that actually works. So just bear with me for a second, and I'm going to try this. Yeah, I'm not sure whether maybe one of you that might be looking can sort of unmute yourself and tell me if you're actually able to see a screen that has something other than me on it.
Yes, sir.
Anybody?
Yes, Professor, we can see the slides. Can you also turn on a light? You're very dark,
Right.
Professor, very dark.
Okay. Yeah, let me see. Hold on a second. Yeah, hopefully that will help. Okay. All right. Okay, so you can see some slides right now. I'm going to play a short little. Okay, so yeah, a little bit about me. As Tara mentioned, I grew up in Bombay and then later in Delhi. My journey started in modern school, where one of my closest, I would say, friends was a gentleman that is Shiv and Tara, whom you've heard's father, Rajiv, who is also listening in. And this is on this slide is just a short kind of list of places that I that sort of were marks in my path. I spent some time in school, and then I spent 4 years down in Madras, which were transformational in a different way. I spent some years in Ohio, getting a master's and a PhD. Probably the biggest and probably most important time that I spent out in the computer industry was with a company called Alias at the time, which is now owned by Autodesk. So I spent a few years working with them. I spent some time with a company called Paraform in the Bay Area. And then in 2002, I started as a professor. And it was never my intention to be a professor. I had no understanding of what it was all about or any desire to be an academic. It just kind of happened that way. And so that's just in terms of timelines and how things evolved for me. And that's in terms of what I was doing around that time. I was a student, and then I was working, and then I was a professor. And but geographically, actually, my life has actually been all over the place, and places that I've lived for probably more than, let's say, a few months. There's a pretty long list down there with this scribble over it to indicate that it's not really a linear list. It's places that I lived, then went back to, returned, left, and it spans a number of continents from certainly from India to the US, to Canada, New Zealand, Japan, Singapore, parts of France, even China. So it's been a fun journey. In terms of what the last 15 to 20, now coming on to 20 years has been sort of my base has been as a professor, as an academic. And this is just a slide I kind of stole off the University of Toronto's on a slide deck that shows a fabulous looking university with some very old buildings, some very new buildings, and if we look at my area, which is computer science, you look in there, my faculty now has been growing and growing in computer science, really, which started out as a discipline by itself, is now kind of a platform that seems to enable just about everything, right? It's sort of a base from which lots of things, whether it's medicine, whether it's finance, whether it's games and entertainment, they're all sort of enabled now. And even more so, it's been so prominent now, given this current lockdown where we've all been isolated and we're just all sort of praying to these pixel screens. And so as a result, if you look at, this is taken off of my department's website, and the department's website lists these as some of the areas that we do research in. And you can see it starts out, some of these things are pretty hardcore and traditional things like theoretical computer science and algorithms and artificial intelligence. But now more and more you're seeing words like health and assistive technology or social networks. Things that are actually quite interdisciplinary are starting to make their way into this melting pot that is computer science. So a little bit about myself. What do I specifically do as a computer scientist? My area is computer graphics and a little bit of human-computer interaction. I have co-directed now for a number of years a lab that I didn't start. It's actually a very well-known and pioneering research lab that works in the area of graphics and animation and human-computer interaction. It goes by a strange name of DGP, stands for Dynamic Graphics Project. It's been around for a long time. This is actually the building out of which we operate in Toronto. The red arrow that you see is actually pointing at my office, and the lab is somewhere inside that building. To give you a sense of what drives me, what's exciting, what I like to do, why I'm driven to the visual sciences. For me, graphics is kind of this blend of art and science, and I always, in my dreams, I kind of maybe thought of myself more as somebody that was kind of art focused, but maybe my talents, or at least my qualifications, were more on the science side, and computer graphics kind of gave me this ability to marry them both together. And it's an interesting area, and it's actually fundamentally challenging. And to give you a sense of why it's so fundamental, I want to play this little, it's a very short video clip. So I'm going to play this. I don't know if you can hear what he's saying. If you can't hear what he's saying, I'll tell you what the short of it is.
Yes, we can't hear, so you'll have to summarize it.
Okay. So I'll stop the video. But basically, as you can see, it's kind of this grainy old footage of a gentleman, and this guy is the head of Lincoln Labs. The person you're seeing, he's a computer graphics pioneer, head of Lincoln Labs, called Stephen Coons. This is back in the Lincoln Labs is one of the big traditional labs that came out of MIT in the States, and this is back, I think, in the 60s. This gentleman is talking to an interviewer, and he's saying, we're going to show you a man talking to a computer, and the interviewer is going, whoa, really? Not with his voice. And the guy is saying, no, don't worry. He's kind of calming him down. He says, no, he's not going to talk with his voice. He's going to talk graphically. He's going to use this language called Sketchpad. And the gentleman actually is a big name in computer science called Ivan Sutherland, that went on to win the Turing Award, which is the Nobel Prize for computer science, and really a landmark name in computer science. And so, but what was interesting about this short clip is the fact that 50 years back, it sounded like just mind-blowing that people could actually talk to computers. And so it seemed like then, at least if you were drawing, you were interacting visually, that might be easier. Today, speech recognition, speech analysis, communicating with a computer is actually almost a solved problem. But my area of computer graphics and working visually is actually still very much an open area. And there's a fundamental reason for this. And I want you all to think of yourself now, like this smiley face that you're seeing over here is think of yourself as an electronic device. As an electronic device, you have a video in, an audio in, You have an audio out. That means you can listen, you can speak. You have a video in, which are your eyes. What we are missing are these amazing kind of reverse projectors coming out of our brain to communicate visually. So we don't have a video out. So we're missing this one port, and that's why this whole area of computer graphics and communicating visually continues to be an ongoing challenge. So the kinds of things that I do, and I'm going to go through this actually very quickly, look at the area of art. They build some mathematical understanding behind it, and then they understand a little bit about human perception, and they build a bridge. So, you know, how do we see things? How do we interpret things? This is something that artists have been looking at for years. So you look at these two very impossible looking shapes, and to us, they seem kind of possible. And you wonder, you know, why this is. If you're wondering why this is, it's quite simply because we see straight lines as straight lines. We see things that are close to each other as close to each other. When people create sculptures, these sculptures actually look like this. They're completely different and crazy. But when you look at them from a particular viewpoint, the mind is tricked into something else. Same thing with visual memory and your shadows. Certainly the shadow that you're looking at on the wall over here looks nothing, you know, creates something very different in your mind from the sculpture that you're seeing over there. So this has gone into a lot of my work. I was involved with a film at one point called Ryan, which is trying to depict things in different ways, in non-realistic ways. I'll skip over the video, but that's the kind of work that I do. And we find that as humans, we are actually subject to a lot of interesting visual biases. So I'm not going to ask you guys, but usually when I do a talk, I show these to people and I say, which of these two looks more like a cube to you? And generally about, I would say 80% of the audience says it's B. And it's not surprising that people say it's B, because I've made this using the standard Microsoft icons in PowerPoint, and that's the default icon. It turns out that that B that you're looking at is about 40% deeper than what an actual cube really looks like. And the actual cube actually looks like what you're seeing, A, which generally seems to most people as actually being quite flat. And so my reason for showing you this is that as humans, you know, not only do we have this video in and we don't have the video out, the problem is actually more complicated than that. We have a biased video in and we don't really know what the bias is. So that's an area that we're studying and so on. So those are the kinds of things that I study. And what's amazing and beautiful for me is that a lot of what I do takes me back to my high school. It takes me back to not even, I think high school, yeah, even a little bit before that. A lot of it looks at simple physics and simple mathematics. And I remember it was interesting, this paper that we were working on a few years back, and my student came to me and he showed me these drawings that student had made. And I knew what they were. He had no idea. He said, why are people making these extra lines? And I said, you know, this is, we had these instruments called mini drafters. Those of you that, you know, might be in class 11 and 12 might be taking engineering drawing. If you're taking engineering drawing, then you know what I'm talking about. If you are not, that's certainly something that used to be offered and was actually quite a fun thing to do, to make, you know, these very beautiful looking but very precise geometric shapes. And so we said, okay, let's try and build a system that's a computing system that will allow people to create things with this. And so my student pointed me at this book, which was a very much a standard design drawing book, and at the time. And one of the things that's great about what I do now is I get to really play. I mean, there's this book, but this is not nearly as exciting as another book that we found with a bunch of YouTube videos about it, called this one, How to Draw Cars the Hot Wheels Way. And there's a guy called Scott Robertson. We studied him, and he creates these incredible three-dimensional structures using drawings. And so a lot of what we do tends to be things like this. One of the big problems that we solved was, how do you take sketches that look like the ones on the left, and by pressing a single button, turn them into something that looks like what happens on the right? Because artists can create these drawings that you see on the left in minutes. But if you ask them to shade them and paint them to create what you see on the right, it takes them hours. And then they take that to their boss, and their boss says, okay, now that was in blue. Can you make it a little more metallic? And can you paint it in red or yellow? And so that's a few extra hours. And so we found that you can actually do this just from those drawings by pressing a button, by using a little bit of mathematics. And so what kind of mathematics? I just thought I'd throw up that one slide up so you'd get a sense. It's the kind of mathematics that you guys hopefully are studying probably right now, looking at vectors, tangents on curves, dot products between vectors, making sure that certain planes are perpendicular to other planes, and looking at things like curvature and playing around with those, coming up with some equations and then solving those equations. And you get some really nice results out of it. So that's the kind of work that I do. Another fun system that we built, which was then bought, turned into a company and then bought by a larger company called Autodesk, allows you to mix models together. So those of you that have heard about 3D printing, this is Autodesk's 3D printing tool now, allows you to basically pull bits and pieces of some model, put them onto other models. So the kinds of things that you see with programs like Photoshop, where you can do things with images and videos, this is allowing you to do those kinds of things with 3D, where you can paint detail, move things across pieces of geometry. So these are the kinds of things that I look at with my students. Here's another example of basically browsing and working with video, where instead of actually forwarding and dragging a slider at the bottom, you actually grab things in the video and move them around. So if you want to know when a car kind of pulled out of a parking lot, instead of trying to go through surveillance footage that may be hours and hours of it, you just kind of drag the car out of the parking lot, or you drag the arm of this baseball player, and so on. So we work with all kinds of people. This is a fun project that I did with the Deaf Center in Toronto, where they wanted to build an identity. And these are some beautiful surface renderings that we were able to create from people actually creating sign language by moving their hands around. And what you see in the corner with these cameras pointing at that gentleman is something called motion capture, where we're able to capture the movement of somebody in real time. And a lot of the special effects, the movie special effects that you see today, are done using motion capture. Another new area is this area of virtual reality, where you can kind of put on these goggles and it transports you to a different space. This is another area that's kind of fun, where we've been working in, where we're trying to think of an internet browser as a way of looking at the world not as web pages but as web spaces, where you are actually in the internet rather than looking at it. So here's an example where you'll see from this video. Again, these videos are playing, so I just then other textures and the sensation of wind and heat and so on, by having the robot arm kind of move around to track a person's arm. So I'm just moving very quickly through some stuff. We can use this the kinds of techniques that I use. They're interesting. In art, they look at history. This is some work that I did on looking at labyrinths and mazes. So it really depends on where you're going. And most recently, one of the things that I'm fascinated with is speech and how you can turn speech into an animated face. Here's a shot from, and this is a company that we have now, a startup called Jolly, that actually takes audio signals in and it produces an animated face. So you'll see this in a few different languages here. Again, the problem is you may not be able to hear what's going on, so that this will be lost. But if you're interested, you can go and look at jollyresearch.com. That's Jolly, Jali, stands for jaw and lip integration. And there's some videos there, and you can see, how you can turn a spoken word into an animated face. So in general, what I'm looking at is trying to create better tools for communication. So compensating for that video out that we miss. So I want to spend a little bit of time because I think, maybe this might be going a little long. I want to spend a little bit of time talking about, what it's all about. If these are the kinds of things that excite you, what should you be doing? I would imagine, in school, if you ask me, was this the direction that I saw myself going into? Absolutely not. I didn't really have much of a sense of where I wanted to go. I think I was somewhat interested in science, and I had good marks, so I took science. And then, everybody was sitting for entrance exams to different engineering colleges. So I sat for those exams and I passed some of those exams. I didn't pass some of those exams. The ones that I passed, I picked the one that most people thought was kind of the right one to go down. And then I ended up doing computer science. And once I was in computer science, within that kind of micro area, I found that graphics was the most appealing to me. So that's where I went into. And then I wanted to go into industry, which I did for a while. And at one point while I was in industry, I liked the fact that I could think about different things and just kind of innovate and invent new things. And academia and universities seem to be the best place to do that. The other thing that I loved about universities was that it gave you a lot of freedom to do what you wanted, but also freedom to organize things the way you wanted. It gave you opportunities to travel, gave you opportunities to work in different places, to work with different people, to work with other students that were smarter than you and younger than you and more hardworking than you, that kind of pushed you. And so it was sort of an exciting area that I kind of meandered into. So it's not, there's no formula there. And I don't think, I think there are very few people that I know that actually have managed to live a formula that they developed at a very young age. So, if you're unsure of which direction you want to go into, join the club. Most of us actually did not and still don't. I still find that, I want to be maybe a rock star when I get a little bit older. Who knows? Or an artist or something different. But if you want to go into the area of computer science, which is actually a pretty attractive area to be in these days, because there's a lot going on, and especially in situations like this, where we're all kind of physically isolated and a lot of our world is kind of cyber driven, computer science becomes very important. The one maybe kind of, if I had to say, what is one thing that is generally really good and useful across computer science, I would say it's a strong mathematical foundation, and not necessarily math. I would say more sort of an understanding of logic. And many of you might be thinking, oh, maybe I should go and learn how to program and write programs in C or the latest language on the block, whether it's Python or a few years back before Python, it was Java. And one of the things you soon realize, and what I tell my students is, it's not about knowing a programming language. It's knowing about the concept of programming and about how to program. So it's more about understanding the logic and how to work with it. And so everything else can be learned. The rest um, is just syntax. It comes out of a book, and now, even better than a book, there are all these online aids to help you along the way. So that's one thing as far as computer science is concerned. If you're interested in going into the area of academia, I would say probably the one thing across the board, and it doesn't matter whether you're a professor in economics or a professor in English or a professor in obscure anthropological history, or whether you're working in accounting and finance or computer science, engineering, it really doesn't matter. I mean, the one thing that is a baseline across it are strong verbal and written communication skills. You need to be able to communicate, make people understand your ideas, and understand other people's ideas. And beyond just make people understand, you need to be able to sell your ideas. And so that's a very, very strong baseline. So, if you're interested in, you're somebody and saying you're interested in science, don't neglect English, don't neglect language. Being able to communicate, very eloquently is very important. Much more in academia, but certainly, I mean, even if you go out into industry, being able to communicate is essential. So I think those are, to me, I find that, to my kids, probably that's the first thing that I want to be able to transmit and consider as important. Just good communication, and then the rest just follows. And then finally, on the life side, I don't know, I mean, there are all these people I've been asked, over the years, I've done a couple of these sort of keynote type speeches, or, talks where you're trying to philosophize. And in the end, I find, most of that is kind of, people are so different that, I think find your own way. It's good to listen to, some big spiel that somebody might have to give you, but at least I don't have one. I think my life has probably, been gone with about 3 principles that seems to have worked well for me. So I'm happy to share them, but, I don't think they're gospel in any way. I would say generally follow your passion if you have one. Many of us have a few passions, a couple of them. Maybe we're not super passionate, maybe it's a mild passion. So we follow them a little bit. And if you don't have one at all, it doesn't matter. Just go with the flow, and, you'll end up in some good place. Most decisions you make are not completely irreversible. What is reversible, what is irreversible is time. And so make sure, if you are working hard, play hard as well. So regardless of whatever you're doing, enjoy the time and enjoy the ride. Enjoy whatever you're doing, because the time is not going to come back. But the big decisions, don't sweat them. Don't sweat the small stuff. That's really most of what I have to say. And I don't know. I'm happy to take questions. I'm happy to turn this into a bit more of a dialogue. So I'll stop now. And yeah, let's hear you guys.
Thank you, Professor. That was a very insightful session. So now we're going to open up the Q&A. So how we're going to go about this is, they have already put their questions into the chat. We will be asking the relevant ones one by one, and you can answer them. So I'm just going to start sharing my screen to share the guidelines of the
So the first question we have is what you spoke about the same as CAD and CAM programs, like Fusion Autodesk 360?
That's one example. So CAD is computer-aided design. CAM is computer-aided manufacturing. Fusion 360 is one piece of software that is owned by Autodesk. That's one area. That's the kind of software that a lot of people that are in the area of architecture and engineering use. But if you go in the area of entertainment, people that are looking to do movie special effects, to create computer animations, they tend to use software such as Maya. I mentioned Maya because Tara had mentioned, a software that I had been involved in the creation of, and that was the one. But there are others. There's a very popular one coming up these days called Blender that people use. That's in the area of design. Sorry, in the area of animation. But there are other softwares that people use for virtual reality. There's the area of computer graphics is just full of all kinds of programs, and those are in 3 dimensions. If you go into 2 dimensions, I'm sure many of you have heard of Photoshop and Illustrator, and the 2D world is not owned but dominated by another big company called Adobe. So I'm sure you've come across things like Acrobat and Illustrator and Adobe's suite of products. So yeah, those are the kinds of software that I'm talking about.
Thank you. Our next question is, if someone wants to become an IES, then what would they have to do if they're in grade 12?
Okay, now I have to show some ignorance and ask you what IES is, because I'm not sure what the acronym actually means. So if you can tell me what IES is, then I might be able to.
So then we'll have to come back to this because they are not allowed
Okay.
to unmute themselves.
Fine.
Tara, next
So
question.
maybe we can move on to the questions, and then we can come back to this one.
Yeah, if they put in the chat, then I'll come back
Yeah.
to this one.
Yeah, sure.
What are some courses that you would suggest we take at school and college, other than the core subjects you suggested, to go into this field?
To go into the area of computer science, I would say certainly math is important. Depending on which area that you go into. So these days, the big hot area is an area called machine learning. Some people call it artificial intelligence. Some people call it deep learning. Some people call it data science. It's all about making use of all this data that we have coming in, that is just literally swamping our computing systems, and trying to make sense out of it by fitting interesting functions and learning features. And so that area is strongly mathematical, and I would say, courses in calculus, whether it's differential or integral calculus, calculus in general, multivariable calculus, those are very useful. Algebra is very useful. Understanding vectors, matrices, matrix math. I wish I had studied more matrix math earlier on. Juggling with matrices is really a lot of what happens in working with techniques on learning, basically being able to work with data. So that's one area that is that I would suggest courses in. If you're in a more theoretical area, then certainly courses in logic are important. And then communication. I cannot overstress being able to write well, communicate your ideas clearly. Many of us think we actually write quite well, but you know, being able to write concisely, clearly, it takes time, it takes effort, it takes practice, and even now I find myself, you know, often writing something and then rewriting it and rewriting it because you know, you think that, oh, you know, I think you know, at one point, maybe in school, when I was in school in Delhi, at least, there was a tendency that if you wrote a lot, like if your answer was long, that was a sign of quality of the answer. And in many ways, actually, the opposite is true. As long as you are communicating all the information, then I would say the best answer is the one that can communicate everything that you have to say, everything that is important, in the least number of words. And that's a challenge. That's not an easy thing to do. So I would say, yeah, don't neglect your English courses. Don't neglect. So those are from the top level, and then things start to become domain dependent. If you are looking at, you know, psycholinguistics or the area of working in speech, there are lots of people working in languages and natural language processing, working in speech. Then, of course, being able to understand languages becomes important. If you're working in the area of biomedicine and biocomputation, then of course taking biology courses and genetics courses becomes interesting. If you're working in the area of hardware, if you're looking at virtual reality, creating these goggles and things like that, then you should be taking physics courses, you know, courses on optics, courses on understanding how the physics of light transport works and so on. So it really depends on the direction that you want to go.
Thank you. Now we have a few questions on the lines of programming languages.
Sure.
So I'm just going to club them together.
Yeah.
So is learning a programming language very helpful in becoming a computer science engineer and in being successful? And also, what programming language would you recommend for future users?
The answer is yes. Even though I mentioned earlier when I was talking, I said, oh, programming languages are not important. It's more important to learn how to program. You still need some example language to understand the concepts when you're learning. It's a little bit like saying, it doesn't matter whether you speak English or you speak Hindi or you speak Tamil or you speak French or you speak Japanese. What's important is you understand how languages are constructed, and you understand the concept of grammar, and you understand tense and all these other bits and pieces that go into building a language. And yes, it's nice to be able to understand those, but to put them into practice, you need some example thing to work with and some example language. And many of us actually learn that in a very, you know, organic way as children when we learn how to speak one or more languages. So similarly, it's very, you know, easy or kind of pedagogical to say, oh, you know, you should understand the concepts behind programming, but to understand those concepts, you should work with some language. So certainly it's very important that you pick up some language. Does it matter which language? And that less. So generally, I would say pick a language that is recent. If you pick a language that's recent, then it's, you know, it's a little more trendy. Lots more people are using it. You can find more support for it. And if you look at what kind of trendy languages are these days, I would say Python is probably among the more trendy languages. So if you had to pick a language today, I would say, yeah, why not Python? I mean, I say that without being a huge Python expert myself. But among the languages today, a lot of people are using Python. Some people are using Java. And then, of course, a lot of the hardcore programming still happens in C and C++, which are languages that were my bread and butter languages. So yeah, these are examples of languages that you could learn. But it's more important than learning the syntax to also understand, why things are put together the way they are.
Is learning a programming language really helpful in becoming a... Okay, I think that's answered. I think Tara
Helpful in
asked
becoming
that.
a computer scientist? Yeah, absolutely. The only area where you might not end up actually sort of writing out programs is if you go into theoretical computer science, where you're more like a mathematician, you're proving theorems about things, you're reasoning, you're using logic. But even there, I mean, at some point, you cannot become a computer scientist or a computer engineer without actually writing a program at all. That, it is an essential aspect, I would say, of your education.
Professor, maybe take the question a little differently, since the question
Okay.
is coming from a high school student. Maybe the question could be also seen as, is it important to learn a programming language while you're in high school, even though the undergraduate program might be computer science?
I see. Yeah, that's right. So that's a good question. I'm not sure. So I mean, as an example, and of course, times have changed. So uh, when I did I went to IIT and I studied computer science. In high school, we didn't actually study computer science. We studied physics, chemistry, maths, uh, English, and engineering drawing. Those were my 5 subjects. And there was no computer science. Some of us, I remember among our friends, had like little PCs at home, and as enthusiasts, we wrote, we learned how to write the odd program in BASIC or some computer language, but there was no formal education there, and it didn't matter. We actually went into the undergraduate program without actually having written any programs at all. I think that's changed actually. So I think now in high school, you guys probably do have a little bit of programming at least. And if you don't, I don't think it's essential. I don't think when computer science, when a college looks to admit you into a computer science program, I don't know whether they actually look at grades that you get. I think they just look at your marks overall, and your general performance if you're taking different kinds of exams and so on. I don't think they specifically are looking for you to have already computer, some formal computer education under your belt. I may be wrong about that, but I certainly don't think that it's a huge prerequisite. But if if you know that you want to go into computer science, then why wait? Why wait till you kind of get into your undergraduate program? You might as well learn something. And if the school that you're in is not offering uh, learning a computer language or a computer science course, there's so much available online. I mean, the kinds of courses that you can find to learn languages and so on is completely amazing. I mean, sometimes, you might even wonder why, why do we even go to school or to university when you can find all the knowledge you want, online. So I don't know. Hopefully that answers your question. Part of this is also a bit of a guessing game for me trying to understand kind of the what you're looking for as an answer behind the question.
Are the skill sets very different? Computer science, just give me a second. Just lost the question. Computer science, engineering, mechanical engineering, and electrical engineering.
Initially, no. So, I mean, as my own example, again, that's the problem when you've been out, when the time when I did my degree was now so long ago, things may have changed, but at least, what is it, 30 years back now or 20 years, 30 years back at the IIT, and the other engineering colleges as well, the first year used to be common across all the engineering disciplines. It didn't matter whether you were doing computer science, mechanical, electrical, and actually often after the first year, people would switch. They try and switch from one stream to another and so on. And they were able to, the reason they were able to do it was because the first year was basically common across all these courses. So, we were studying the same kind of physics and math and chemistry and basic courses. And even if we were studying a computer course, people in electrical engineering were studying that course as well. And same with, this was common across these courses. So yes, I mean, the basis is common. At some point, excuse me, at some point, things start to diverge. Certainly, mechanical engineering, you start to look at more things related to engineering mechanics. And in electrical engineering, you start to look at more either things related to heavy engineering, or in electronics, you're looking at circuits and the hardware, computing hardware. So at some point, things start to get more specialized. That said, when I look at students, students come to me for a master's sometimes. They are not computer science, even they're coming to computer science for a master's degree, but their bachelor's degree was in something completely different. Their bachelor's degree was in mechanics or in some other kind of engineering. And what they want to do is they want to use that knowledge in an applied sense in the computer science setting. So computer science itself may be a little unique in that sense that it absorbs a lot of people from very diverse disciplines that then use computers as a platform to kind of do new work. So it has that very cross-disciplinary area, cross-disciplinary nature to it. But a lot of the other engineering, at least early, just after high school, if you go into electrical or mechanical or computer, initially you're studying very similar things. Now, whether you can switch from one to the other freely, that really depends on the university that you end up going to, the educational system that you're in. Those things are easier or harder in certain places. And that is very university specific. Yeah, so that really is depends on where you are.
So, Professor, we have a couple more questions, but we have only like 5 minutes left.
Yeah.
So let's
I can
budget
try
accordingly.
and if you would like, you can go through your questions. I can shorten my answers. I think part of the problem may have been that my answers might have been a little long, and it's just that I wasn't completely sure of what was giving you guys useful information. So So the answer may have been a little more
No worries.
rounded.
So we'll try not to overshoot as much as
Yeah,
possible.
we can.
So
Sure.
let's go on to the next question.
Yeah, we can try and go through them quickly.
What tools would you suggest to a beginner to learn the concepts of programming?
What tools? I don't have a specific tool in mind. I would say I would say two things. One is pick some book or some course that is less specific to a language and talks more about concepts like iterations, loops, conditionals, recursion. These are more kind of standard algorithmic concepts. So that's one suggestion. The second suggestion is a little bit like I've heard some friends of mine, when teaching people how to play musical instruments, give them the tip that instead of going along some complicated very kind of boring looking route, start to play some songs that you like. So similarly, pick some interesting problems, pick a game that you might want to replicate, or pick something that you think is really fun for you, and start to write programs for that. And then you will just learn along the way. So those are the two quick tips.
Is it important to have an understanding in the field of art to pursue this field?
No, not at all. In computer science in general, no, you absolutely not. Even my area of computer graphics, a lot of people don't. A lot of people that look at animation actually study the physics of animation. Many of them come from mechanical engineering backgrounds. They study dynamics, collisions, various kinds of, basically engineering, mechanics, and physics, and those kinds of things. Some people understand optics. My area in computer science, in computer graphics, so I'm going very narrow down, is more art focused and art driven. So having an understanding and appreciation of art is useful there. It's desirable, but it's absolutely not necessary.
What do you feel is the most promising field in the area of computer science?
Promising. They're all promising. Yeah. I mean, these days, what are the big hot topics? The hot topics in computer science these days are artificial intelligence, machine learning, deep learning. They're promising. They're also probably the more lucrative areas. But all of computer science is really lucrative at this point. So that's one hot area. My area of graphics is always gratifying because you can see your results as pretty pictures. Um, of course, there's a lot of work happening in computational medicine. So there are people that go and get medical degrees and then go into computer science. That's also a very promising area. Genetics, especially now, with things like when pandemics like this show up, that's a hot area. The other big hot area is social media, social networks now. That's also connecting people. And frankly, by the time you guys graduate from high school and get into colleges and really start into a career in computer science, that the hot areas will have moved on.
They're exiting.
Are you mad? They can see
What?
you exiting.
I know.
Yeah.
How do we get started with the field of computer graphics at home?
Get started with the field of computer graphics at home. Good question. I would say if you like video games or you like some kind of a computer application, whether it's a painting application or a drawing application, find it, study it, and then look for, just Google, how you might be able to program something like that. And there are all kinds of interesting platforms that allow you to, if you want to program a game, there are game engines like Unity is a very simple way to get started. You download it, it has a very nice little editor, you can drag and drop things, and you can start programming like that. JavaScript is a great way. You can actually just, on the internet, you can create little graphics programs. And if nothing else, I teach a graphics course at the University of Toronto. You can go to, I have a web page. You can put my name into Google with University of Toronto and just follow. The course number is 418418. And you can look at the example programs there and build off that. So there's no one way, lots of fun ways to get into graphics.
So we do have quite a few questions left, but let's restrict it to 2 more questions.
Okay.
So with the field of computer science becoming a very popular field, what do you recommend students do to differentiate from the crowd?
Well, that's something that will come, I would say, come later down the road. For now, I would say, if you want to get into computer science, join the crowd and, start to get an understanding about it. Worry about differentiating yourself a little later down the road. But ways to differentiate yourself, certainly when I look at applications and people, certainly at the master's level and later on, I'm looking at things that they've done that are different. Marks are great, they've done all the courses, they know all the languages, but what have they done that is a little different? Have they actually written some interesting programs that solve something? And you see this on the internet every now and then. When this pandemic broke out, there was some 18-year-old kid that was in the news because he wrote a little application that was able to scrounge the internet and track the rate of the spread of this coronavirus in different countries. And then people started to use his website. So that's a really good example of ways of a way of differentiating yourself from the crowd. Right now, because of the internet, you can be your own marketing platform. You just have to do something interesting and put it out there.
So we actually have a lot of questions revolving around computer scientists. So maybe give us a brief insight into what their role is and what they do.
Okay. So, well, what do computer scientists do? Computer scientists basically look at problems. The problems can be things that can be quite complicated, whatever they can be problems such as taking a sound signal from a microphone and then turning that into text and understanding that speech and maybe responding to it. Those are the kinds of problems that people have. Other problems that people might come is, I have all this data, I want to try and make some sense out of it, visualize it in certain ways, process it in certain ways, and come up with some answers based on that. In medicine, computer scientists are trying to understand how certain chemical structures work and react with other structures, how things evolve, how things mutate. There's a lot of work in understanding genetics, understanding the progression of diseases, and helping find factors that doctors can start to take into account. In the area of computer graphics, computer scientists are always looking for what's the next, what's what's the next cool effect that we can show you in a film or in a game. So computer scientists, what do? We look at problems and we try to find ways to solve them using a computer. Sometimes these are problems that humans have been solving, and usually if we are looking for a computer to solve them, the reason is because humans either take a lot of time, or it's inefficient to solve, or it's tedious, or it's boring. The role of computers, at least philosophically, is not to put humans out of jobs. It's to basically do the boring parts of human jobs and leave humans free to do what they do well, which is come up with creative solutions, creative insights, and creative inventions, and the parts that are creative, are still very much in the human domain. And then what these programs and what scientists allow us to do is do the painful parts using computers. Shiv?
Yeah, sorry, I was unable to unmute myself.
No worries.
So to conclude the session, thank you. We would like to thank you, Professor, for giving us these insights into the field of computer science and graphics. Before everyone logs off, just a quick reminder that our next session will be on Sunday at 9 p.m. with Dr. Neha Joshi and the CEO of Bhartiya Hospital, Mr. Abhishek Bhartiya. Thank you all for joining us again, and thank you, Professor.
Thanks, Shiv. Thanks very much, and thank you all for taking this time to listen. Hopefully, some of this was useful, and I wish you all luck with with the rest of your schooling and with college and such fabulous lives that you have awaiting you. One last thing, actually, if any of you have questions or something, Shiv has a contact for me. I mean, please feel free to reach out and I'll be happy to try and respond. Okay.
Thank you. Thank you again.